All right, so today we're going to talk about properties of conics and focus on ellipses and hyperbolas. So when we draw a line from our two focal points, here's our center, here's our focal point number 1, here's our focal point number 2. When I draw a line from focal point number 1 to any point on the ellipse, which we're just going to call x comma y, this gives me a focal radii. And I will have a secondary focal radii from focal point number 2 to that same point. The length of that line segment from focal point number 1 to P is represented by the quantity A plus EX, and the length of the line segment from focal point 2 to the point P is A minus EX. These are the lengths of the focal radii. So the A and the E are things that we have dealt with before. E we know is eccentricity. The A is the value that's seen in the denominator, but more specifically, we're going to call it the distance from the center to the vertex, to either vertex. X is going to be the x coordinate of whatever point that you're dealing with. And we're going to call that point x comma y. Next thing is directrices. If you have one of them, it's a directrix, but if you have more than one, it's directrices. It's a vertical line determined by the equation x equals a over e. One thing to know is that an ellipse has just one, but a hyperbola has two. The Focus-Directrix property of an ellipse is that for any point P, which we're going to call x comma y on the ellipse, the ratio of F2P, which is the distance from the second focal point to point P, to PD, which is the distance from P, the point on the ellipse, to a perpendicular point on the directrix, which is shown in the purple, is equal to E, which is the eccentricity of the ellipse. Another way to write all of that is that F2P over PD is equal to E. Practice problems, it wants us to find the lengths of the focal radii. So we're given this point xy, and we can tell from the equation that A is equal to 15 and B is equal to 5. Using that, we can use the equation c squared equals a squared minus b squared to determine c. So c squared equals 15 squared minus 5 squared. And that gives us 225 minus 25, which is 200. So c is equal to 10 root 2. Using c, we can figure out e, since e is equal to c over a. So we can do e equals 10 root 2 over 15, which reduces to 2/3 root 2. All right, now that we have e and a, we can then figure out what are the lengths of the focal radii. All right, so using our formulas from above, we have the distance between focal point 1 and point P is A plus EX. So that would be 15 plus 2 root 2 over 3 times 9. So if we simplify that, the 9 times 2 is 18 divided by 3 is 6. So this will become 6 root 2. So that is the first focal radii length. And then the second one is F2P equals A minus EX. So that would be 15 minus 2 root 2 over 3 times 9, which is 15 minus 6 root 2. And that's the second focal radius length. In number 2, you'll notice that there's a subtraction sign, so that tells us we're working with a hyperbola. But in any case, we know we need to divide by 900. So we need to simplify this equation. And 900 divided by 25 is 36. So this first fraction will become x squared over 36. And 900 divided by 36 is 25. So this will be y squared over 25 equals 1. All right, using that equation, we know that a is equal to 6, b is equal to 5. We can calculate our c by using a squared plus b squared because it's a hyperbola this time. So that gives me 36 plus 25, which equals 61. And so c is equal to root 61. All right, to find the foci, we know that the center is at 0, 0, and the hyperbola opens left and right since the x squared is the positive fraction. So from there, we know that we have to go root 61 in each direction, left and right. So we're going to do 0 plus or minus root 61, comma 0. So these would be our foci. All right, now let's find eccentricity, which is c over a. And that would give me root 61 over 6, and that does not simplify any further. So that is done. And then, just like an ellipse, the equation is x equals a over e. But for a hyperbola, there are two directrices, and that would be negative a over e, a vertical line at that value. So I'm just going to note that for a hyperbola, it has two of these. All right, so let's actually calculate them. So we've got x equals a, which is 6 over root 61 over 6. All right, if I convert that to multiplied by the reciprocal, I get 36 over root 61, which we know we have to rationalize. So our final equation is x equals 36 root 61 over 61. And then it's going to be the opposite of that because we're going to do negative 6 over root 61 over 6, which we will skip down to the simplified version, which is negative 36 root 61 over 61. And these are the equations of the vertical lines that are our directrices. Moving on to problem number 3, we are going to write the equation of the ellipse in standard form. And the focal points are at 1, 0 and negative 1, 0. So that tells us that c is equal to 1. And we also know that the center is equal to 0, 0. So first thing I'm going to try to do is come up with some equations. Well, we know that E is equal to C over A because that's our eccentricity equation. The directrix has an equation x equals A over E, and in this case it equals positive 4 and negative 4. So we're going to look at A over E equals 4. And if I have these two equations, really the only thing I can try to substitute is that C is equal to 1. So E times A is equal to 1. But then I also have another equation that says A over E is equal to 4. So if I move things around, I get A equals 4E, but that E is equal to A over 4. And I can now take that and substitute it into this equation. So I have A over 4 times A equals 1, which becomes A squared equals 4. All right, so I have A squared, I have C. Now if I use my C squared equals A squared minus B squared, because it's an ellipse, we're going to subtract, I can put in 1 squared equals, now I already know A squared is equal to 4, so I don't need to square it again. And that I'm going to subtract b squared. So if I move b squared to the other side and I do 4 minus 1, I get 3. All right, so now that I know a squared and b squared, I can write my ellipse equation, which is x squared over 4 plus y squared over 3 equals 1. Now, normally I would just leave it like that, but they want it in standard form, so we're just going to multiply everything by 12, and that gives you 3x squared plus 4y squared equals 12, and that is all we needed to find for this problem. For the last problem, we have to come up with an equation of a hyperbola. And we know the focal points are at plus or minus 2, 0, so that tells you that c is equal to 2. And the directrices are at x equals positive 1 and negative 1. So I know that x is equal to a over e, which is now equal to 1. All right, I know another thing is that the center is at 0, 0, because the focal points are 2 units away from 0, 0. Now the eccentricity formula is E equals c over a. And we do know c, we know that that is equal to 2. So I can do e times a is equal to 2, and a over e is equal to 1. So I'm going to try to substitute. So if I multiply each side by e, I get a equals e. All right, so I can now substitute. A can go in for e, so I would get a times a is equal to 2, which is a squared equals 2. And now I just need to figure out what b squared is. So for a hyperbola, it's c squared equals a squared plus b squared. And that gives me 2 plus b squared equals 2 squared. So 4 minus 2 is 2, and then b squared must also equal 2. So if I do my hyperbola equation, since my focal points were at 2 and negative 2, I know that my hyperbola is going to open right and left. So I want to start the equation with x squared, and then subtract y squared and equal it to 1. A squared is 2, and b squared is 2. So this answer would normally be fine. However, it does ask you for standard form. So I'm going to multiply by 2, and that gives me x squared minus y squared equals 2. And that is the end of today's video. Have a good day.